Hey guys, this is Reed again. We're on part 3 of Unit 4. Man, what a unit. Still covering dimensions, but we're going to tackle that not so complex subject of tolerance. Tolerance is the acceptable margin of error. Now, you're going to get a measurement on your blueprint, and it needs to be as spot on as you can possibly make it. And if you're off a little bit, sometimes that's okay, but that'll be indicated at the title block as a plus or minus symbol. This is what you'll see. So tolerance being the acceptable margin of error, and it's expressed as a plus or minus symbol. For linear dimensions, you'll have a fraction. And let's say your original measurement was 12.5 inches with a tolerance of 1/8 inch, plus or minus. So the tolerance, remember in the last unit, in Unit 3, we were talking about something called a title block. And that's a lot of information is found in that ruled block at the bottom right of every blueprint. So your tolerance can be found there generally. Now your linear dimension here, 12.5 inches plus or minus 1/8 of an inch. Now what it quite literally means plus or minus. So we're going to take 1/8 of an inch and add it to 12.5. And you're going to end up with 12 5/8 of an inch. Alright, then we're going to take that 1/8 inch and subtract it from 12.5. And you get 12 3/8 of an inch. Now after you fabricate this part, as long as it's within 12 3/8 and 12 5/8, if it's anywhere in that window, it's acceptable. And that's what tolerance stands for. So you not only have linear, fractional tolerance, I forgot to put it up here, but you can have decimal as well. You can have a plus or minus 0.02 of an inch. So if you had, let's say, 12.5, which is the same measurement but expressed in decimals, plus or minus 0.02 of an inch, your maximum would be 12.502, and the minimum is 12.498, and as long as you're within that window. And here is where we discover that when a decimal is used, it indicates precision. So you have 0.02 of an inch tolerance. That's pretty tight. If you take 1 inch and you divide it into 1,000 different parts, and only 2 of those is how much you're allowed to be off, that's a really precise measurement. Generally, you're getting off into machine tool technology or maybe millwright work or something like that. In some trades, you do have to be that precise. With pipe fitting, iron work, and things like that, generally if you're within 1/16 of an inch, nobody's going to say much. But you do have more precise trades. So there's your fractional and your decimal tolerance. Now, angular dimensions. A lot of people don't know that every degree is broken up into 60 equal parts. Just like an hour is broken up into 60 minutes. So 47 degrees. Let's say we had 47. I'm going to make a side note over here. 47.5 degrees. That's 47.5. Another way to say that is 47 degrees and 30 minutes. Minutes are your unit of measurement on an angle. Now, if I have this single sign, usually with a linear dimension, the single mark means feet. But when it comes to angular dimensions, it means minutes. So you've got plus or minus 5 minutes. And we're looking for our limits of size here. So 47 degrees plus or minus 5 minutes. Your maximum measurement, let me get this other business out of the way. Your maximum measurement is going to be, well, I can turn that into 47 degrees and 5 minutes. And your minimum is going to be 46 degrees and 55 minutes, because you took 5 minutes away from that 47, so it dropped you down to 46 degrees and 55 minutes. The only other thing I want to go over in part 3 here are a couple of terms that you'll find at the end of the unit. And we're still not done. I'm going to come back and hit scale sizes and thread specifications in our next video. But right here, I want, they have this at the end of the unit when I can best express it here. Your basic size is going to mean the dimension given, what they would like. That's your basic size. Your actual size is after you get done with the fabrication of the part, whatever that measurement is, it's the actual size. Nominal size is an approximation. If you've ever bought a 2x4, you know that that isn't actually 2 inches by 4 inches. It's more like 1 5/8 and 3 1/4 or something. But that's a nominal size. It's an approximation. They use that on lumber. They use it on pipe. We're going to come up on piping in Unit 6. That's a few videos from now. But then you have limits of size. And limits of size is your maximum and minimum. Those are your limits. So get familiar with this terminology, guys. It feels good to sound like you know what you're talking about. You look like you know what you're doing. It feels good. It feels really good to be good at something, and I'm rooting for you. So any questions you have, please don't hesitate to ask me or whoever your current instructor is. Thank you.